Let's talk about OSI model. Hello and welcome to PepTech Talks. Keep liking and subscribing to the channel to get more new upcoming videos. If you are here, that means you are ready to step into the world of cybersecurity and things get serious from here on. I am serious, but I am not boring when it comes to cybersecurity. As discussed in my part 1 video, we are going to have two parts for this video presentation. The reason being OSI is a big topic and I would not expect you to sit for 30 minutes straight and go through this video without a coffee, tea or a smoke break. So enjoy the second part with an introduction to OSI model. Welcome to the part 2 of our video series on the OSI model. In this video, we'll cover the 7 layers of the OSI model. We will explore the functions of each layer, the protocol used, and common security risks associated with these layers. Understanding the OSI model is a critical component of network security, and by the end of this video, you will have a comprehensive understanding of each layer and its role in securing your network communication. The physical layer is the lowest layer in the OSI model and deals with the physical transmission of data over a network. It is responsible for the physical aspect of network communication, such as the transmission medium, data encoding, and signal modulation. The physical layer ensures that data is transmitted from one device to another without any errors or loss of data. The following are the key components of the physical layer. Transmission medium. The transmission medium is the physical pathway that carries the data from one device to another. It can be a wired medium, such as copper or fiber optic cable, or a wireless medium, such as radio waves or infrared signals. Connectors. The connectors are physical interfaces that connect the transmission medium to the network devices, such as computers, switches, and routers. Example of connectors include RJ45 jacks, fiber optic connectors, and BNC connectors. Physical signaling. The physical signaling refers to the way that data is transmitted over the transmission medium. This can include digital or analog signaling, voltage levels, and frequency modulation. The physical topology refers to the physical arrangement of the network devices and transmission medium. This can include bus topology, ring, mesh, star, or hybrid topology. Some of the key ports and protocols associated with the physical layer include Ethernet port. It is a widely used LAN protocol that operates at the physical layer and the data link layer of the OSI model. It uses a variety of physical signaling methods such as twisted pair, coaxial cable, fiber optic, support speeds between 10 Mbps to 100 Gbps. RS-232. It is a standard protocol used for serial communication between devices such as a computer and a modem. It uses a single-ended signal and supports data rates up to 115 kbps. USB or Universal Serial Bus is a common interface used for connecting peripherals such as keyboards, mice, printers to computers. It uses differential signals and supports data rates up to 10 Gbps. HDMI or high definition multimedia interface is a digital interface used for transmitting audio and video signals between devices such as a DVD player and a TV. It uses TMDS or transmission minimized differential signaling and supports resolution up to 4K. But now you will even find televisions with 8K. TCP/IP. It is a suitable protocol set used for data transmission over the internet. It includes several layers of protocol, including the physical layer, data link layer, network layer, transport layer, application layer. So, overall, in summary, the OSI model, which is responsible for the physical transmission of the data over the network, and this physical layer includes connectors, physical signaling, physical topology, supports a variety of ports and protocols such as Ethernet, RS-232, USB, HDMI, and TCP/IP. The data link layer is the second layer of the OSI model and is responsible for the reliable transmission of data over a single network segment. It ensures that the data is transmitted without error or loss of data and provides mechanisms for flow control and error detection and correction. The data link layer is divided into two sublayers, the logic link control sublayer and media access control sublayer. The following are the key components of this layer. Frame. The data link layer divides data into frames, which are sequences of data that include header and trailer information. The header includes source and destination addresses, while the trailer includes error detection and correction codes. Addressing. The data link layer uses physical addresses known as MAC addresses to identify the source and destination of the data. MAC addresses are unique identifiers assigned to network interface card or NICs. Flow control. This mechanism is used to manage the rate of data transmission between two devices. This prevents data loss and buffer overflow. Error detection and correction. The data link layer includes mechanisms for detecting and correcting error in data transmission. This includes cyclic redundancy check codes, which are used to detect errors in frames. Some of the key ports and protocols are Ethernet, which is widely used LAN protocol that operates at both physical layer and data link layer of the model. It uses a variety of physical signaling methods such as twisted pair, coaxial cable, fiber optic, and support speeds from 10 Mbps to 100 Gbps. Wi Fi, which is a wireless LAN protocol, operates at the physical layer and data link layer of the OSI model. It uses a variety of wireless signaling methods such as radio wave and infrared, and supports speed up to 10 Gbps. Frame relay is a WAN protocol that operates at the data link layer of the OSI model. It uses a packet switching network to transmit data between remote locations. PPP, or point to point protocol, is a WAN protocol that operates at the data link layer of the OSI model. It is used to establish a direct connection between two devices, such as a computer and a modem. Address resolution protocol is used to map IP addresses to MAC addresses. It operates at the data link layer of the OSI model and is used to identify the MAC address of a device on the same network segment. The network layer is the third layer of the OSI model and is responsible for routing of data between different networks. It provides logical addressing, which allows data to be directed to its intended recipient across multiple network segments. The network layer is also responsible for fragmentation and reassembly of packets, as well as error handling and congestion control. Following are the key components of this layer. Packet. The network layer divides data into packets, which include header information that identifies the source and destination addresses of the data. The network layer determines the best path for data to travel between different networks. This involves selecting the most efficient route and directing the data through intermediate network devices such as routers. The network layer uses logical addressing to identify the source and destination of the address. This includes Internet Protocol addresses or IP addresses, which are unique identifiers assigned to devices on a network. Fragmentation and reassembly. The network layer can fragment large packets into small ones for transmitting across the networks with smaller maximum transmission unit or MTU size. The receiving device can then reassemble the packets into their original form. The network layer includes mechanisms for detecting and handling errors in data transmission. It also manages network congestion to ensure that data is transmitted efficiently. Some of the key ports and protocols include IP, or Internet Protocol, which is used to transmit data between networks. It is responsible for logical addressing and routing and is the primary protocol used on the Internet. ICMP, or Internet Control Message Protocol, is used to send error messages and operational information about network condition. It is often used for network testing and troubleshooting. IGMP, or Internet Group Management Protocol, is used by devices on a network to join and leave multicast groups. This allows them to receive data that is transmitted to multiple devices at once. BGP, or Border Gateway Protocol, is used for routing between different autonomous systems, or AS, on the internet. It is used by internet service providers to exchange routing information. Open Shortest Path First, or OSPF, it is a protocol used for routing within a single autonomous system. It is often used in large enterprise networks. The transport layer is the fourth layer of the OSI model and is responsible for providing end to end communication between applications running on different hosts. It ensures that data is transferred reliably, efficiently, and accurately across a network. The transport layer is where the most common transport protocols are implemented, including TCP, or the Transmission Control Protocol, and UDP, or the User Datagram Protocol. TCP is a connection oriented protocol that establishes a reliable and ordered data transfer between hosts. It uses a three-way handshake to establish a connection and provides features such as flow control, congestion control, and error detection and correction. Some popular ports are port 20 for FTP data, port 21 for FTP control, port 22 for SSH, for port 23 for telnet, port 25 for SMTP, port 80 for HTTP, and port 443 for HTTPS. UDP, on the other hand, is a connectionless protocol that provides an unreliable and unordered data transfer between hosts. It is often used for real time communications such as voice over IP and video conferencing, where speed is more important than reliability. Some common UDP ports being port 53 for DNS, port 67 and 68 for DHCP, port 123 for NTP, port 161 and 162 for SNMP, port 500 for IPsec key exchange, or IKE, and port 5060 and 5061 for SIP, or Session Initiation Protocol. The session layer is the fifth layer of the OSI model and is responsible for establishing, managing, and terminating connections between applications running on different hosts. It provides services such as session establishment, synchronization, and checkpointing to ensure that communication between applications is reliable and secure. The session layer is also responsible for maintaining the session state information and recovering from errors that may occur during communication. The session layer does not have any specific protocol or port numbers associated with it, as it primarily provides services to the layer above it. However, some application layer protocols make use of session layer services such as NFS, or Network File System. This protocol allows remote access to files and directories over a network. It uses the Remote Procedure Call, or RPC protocol, to communicate between hosts and relies on the session layer to maintain a persistent connection between the client and the server. Structured query language. This is used to manage relational database and is often used in client server communication or applications. The session layer is responsible for managing the SQL sessions and transmissions, ensuring that multiple queries are executed as a single unit of work. X.400. This protocol is used for email exchange and relies on the session layer to establish and manage email sessions between hosts. And last one, Apple Talk. This protocol is used in Apple networks and relies on the session layer to establish and manage connections between Apple Talk devices. The presentation layer is the sixth layer of the OSI model and is responsible for ensuring that data is presented in a format that is understandable by the receiving application. It is responsible for data compression, encryption, and decryption, and is used to convert data from one format to another. The presentation layer does not have any specific protocols or port numbers associated with it, as it primarily provides services to the layers above it. However, some application layer protocols make use of this layer, such as MIME, or multipurpose internet mail extension. This protocol is used to extend the format of email messages to support multimedia content. The presentation layer is responsible for encoding and decoding MIME messages, ensuring that they can be interpreted by email clients. SSL or TLS, secure socket layer or transport layer security. These protocols are used to ensure secure communication over a network, such as between a web browser and a web server. The presentation layer is responsible for encrypting and decrypting data, ensuring that it is transmitted securely. JPEG, or Joint Photographic Experts Group. This image compression format is widely used on the internet to reduce the size of image files. The presentation layer is responsible for compressing and decompressing JPEG images, ensuring that they can be displayed correctly by web browsers. The final layer, application layer, is the seventh and topmost of the OSI model and is responsible for providing services to end users and applications. It includes all the protocols and interfaces that are required for applications to access network resources and communicate with other applications. There are large number of protocols and port numbers which are associated with this layer, as it encompasses all the protocols that are used by end user applications. Some of the common ones are HTTP, or Hypertext Transfer Protocol. This is used by web browsers to communicate with web server and is responsible for transfer of web content. The default port number is port 80. HTTPS, or Hypertext Transfer Protocol Secure. This is a secure version of the HTTP that uses SSL or TLS encryption to protect communication between web browsers and servers. The default port number of HTTPS is 443. FTP, or File Transfer Protocol, it is used for transferring files between hosts and is often used for uploading or downloading files from a web server. The default port number is port 21. SMTP. This protocol is used for sending mail messages between hosts and is responsible for transfer of email messages. The default port number is port 25 and it stands for Simple Mail Transfer Protocol. Post Office Protocol version 3, or POP3. This protocol is used for retrieving email messages from a mail server and is responsible for the transfer of email messages. The default port number is 110 or 110. IMAP, Internet Message Access Protocol. This is used for accessing email messages stored on a mail server and is responsible for transfer of email messages. The default port number is 143. DNS, or domain name system. This protocol is used for resolving domain names to IP addresses and is responsible for translating domain names into IP addresses using port 53. Telnet, this protocol is used for remote access to a command line interface and is responsible for transfer of text based commands. The default port number is port 23. Now, to summarize, the OSI, or Open Systems Interconnection Model, is a framework used to standardize communication between different computer systems. It is used in network security as a reference model to help organize and understand the different layers of network communication and the associated security concerns at each layer. The OSI model can be used to identify and address vulnerabilities in network security. By examining each layer of the communication process and identifying potential security risks, it can also be used to implement security measures such as encryption and authentication at different layers depending on the specific security needs of the network. Overall, this model provides a useful framework for understanding and addressing network security concerns. By breaking down the communication process into discrete layers and identifying potential vulnerabilities and security measures at each layer. If you liked the video, please click on the like button and leave me a thumbs up. And also, please kindly subscribe to the channel. Thank you.